start off just with a quick list of steps, basically what goes into graphing rotated conics. If you want to write these down, that would be fine. It's really nothing fancy. Okay. So the first step is going to be to rotate your axes. Remember, like, that's what we're doing. We're eliminating XY term by rotating the axis through an angle theta. So we just want to draw the new x prime, y prime axes. Okay. Then you'll go to your equation. So step 2 is use the values from the standard form to plot the points. So we're going to look back at number 19 from our homework. We're also going to look at the problem from our notes yesterday. You have to do the work to eliminate the x prime, y prime term, or the xy term in the original problem. You get a new standard form with no xy term, and then do just like we used to do. What's A, what's B, where do they go? Okay, we're going to plot the points. And then you just sketch a quick graph of what the conic looks like. You do not have to label the points, so I'm not going to ask you what are the vertices of the ellipse or what are the vertices of the hyperbola. Not a question I ask. You don't have to find foci, so we don't have to do like c squared equals a squared plus b squared or c squared equals a squared minus b squared. None of that happens. All we do is we get the points we need to get the shape, draw the shape, and be done. So it's a lot less work. I'd say a graph for your rotate conic should take 2 minutes, like, compared to a graph for a regular conic.
Okay, so I know it's titled graphing, but are we going to be like working backwards with these? Or are you going to...
No. Oh. Okay, so this is yesterday's example problem. Okay, and you can either go up to your notes from yesterday and do your work up there. You certainly don't need to write everything down. Yesterday we did xy plus 2 equals 0. We did the discriminant to classify the conics, so we know that when we graph it, we're going to draw a hyperbola. Okay, so we know what shape to expect. We found the angle of rotation, which is our step 1. We're going to use the angle of rotation pi over 4 or 45 degrees to rotate our axes. Okay, and then we're going to use, we did all this work, we're going to use all this stuff. We got the standard form here at the end, y prime squared over 4 minus x prime squared over 4 equals 1, to find the values of a and b and graph the hyperbola. Okay, so here's where I would start. I'll graph a regular xy coordinate plane, like you always have done. And then I will use my angle of rotation to rotate the axes. So remember we said in our notes yesterday, the axes will rotate counterclockwise through the angle theta. We said earlier theta was 45 degrees or pi over 4. So I'm going to take the horizontal x-axis, rotate counterclockwise 45 degrees, and label this axis, should go through my origin, right? Okay. This is my new x prime axis. If I rotate the x-axis simultaneously, I'd be rotating the y-axis, so rotate that counterclockwise 45 degrees and label that y prime. So now you really have two sets of like coordinate axes. What you need to do at this point is let the black set, the original XY plane, fade away to the background. You're going to be focused on what is my red set, right? The new x prime, y prime. That's where we're going to graph this hyperbola. You have the benefit of having a piece of paper or a notebook, and you could literally rotate your paper or your notebook so now that's sitting at you like a regular XY axis, right? Okay, so if you wanted to, you could rotate it. This is a hyperbola. Which value is your a squared? A squared is 4. Which 4?
Left 4.
The one in front. Okay, so a squared is 4. That means a is 2. And a is paired with which axes? Y prime. Okay, so I want to go to my y prime axis, and I have a center point at 0, 0. Okay, so I'm going to go to my y prime axis, and I'm going to go up 2 on the y prime and down 2 on the y prime. That's because a is equal to 2. Okay. Those are going to be my vertices because that's a, right? Okay, so maybe I'll label those B and B, just so I remember. Those are my vertices. Now, if we were going to graph a hyperbola regularly, we would use B. So the other value is my B squared, and in this hyperbola, B also happens to be 2, which is fine. Okay, they don't always have to be the same. And that's paired with the x prime, so you should count left and right 2 on your x prime axis. And I'm going to make like little points there. They're not really points on the hyperbola, right? Those B values. Do you remember what we did with A's and B's in the hyperbola?
Make a rectangle around
Make the rectangle. Okay, so if this were classified as an ellipse, then we would just draw an ellipse with those 4 points and be done. Okay, but this is a hyperbola, so we need the rectangle. And in this case, it's actually a square, because your A and your B are the same. And then use the diagonals to draw your asymptotes. Because we rotated 45 degrees, our asymptotes are actually the original x and y axes, right? So those are my asymptotes. And then the last step is just go back to your vertices and draw your hyperbola so it approaches the asymptotes. It should open up because it has y prime first. Your hyperbola should open up around the y prime axis. That's all I have to do.
Like, just looks weird.
It looks weird, but like if you have your paper and you rotate it, I mean, it's nothing different than what we did to graph a regular hyperbola. Okay, you're just doing it on the new set of axes. Did you have a question, Mason?
Uh-oh, no.
Now, I'm not going to ask you where the vertices are because, like, we would normally say, like, the vertices are at, like, 0, 2, and 0, negative 2, because we went up and down on the y, right? But we're actually working on the y prime axis. So if you imagine this vertex point actually in the original coordinate plane, which is the real x and y, we're going left some value and up some value. So it's not like the point 0, 2 that would be on the y-axis. So we would need to do a whole lot of other work to find the actual ordered pairs, and we're not doing that. So I'm not going to ask you what those points are. I'm not going to require you to graph foci, so you don't have to do anything with C. You just get the basic shape and be done. So just really quickly, we'll do number 19 over here on the sideboard.
Left.